Okay, so here we're on 7.3 part 2. So the second part of 7.3 is where we have to find the least common denominator, or the LCD. So remember that in order for us to add or subtract fractions, there must be the same denominator. So if they do not have the same denominator, you have to find the same denominator, or the denominator that would be common to all fractions that are present in the problem. So right now we're just going to go through some basic math concepts of just trying to remember about finding an LCD without looking at variable components right now. So we're looking at 1/3 and 1/2. If we needed to find the least common denominator for 1/3 and 1/2, we would just look at the denominators. And essentially what we would do is we would say, okay, what number can both 3 and 2 divide into evenly? But what we want to do is we really want to look at it because finding the LCD is really about finding factors. All right? So you find the factors. So you find factors for each one. All right, so factors of 3 are just 3, factors of 2 is just 2. So when we look for the LCD, you're going to pull out each factor that's present. So 3 times a 2. So the LCD would be 3 times 2, which is a 6. So you do the factors of each denominator. All right, so you find the factors of each denominator. You pull out individual factors. All right. So for 3 and 2, we use 3 and 2 because that's all. So we pulled out the individual factors. We used the 3 and we used the 2. So let's look at another problem. What if we have 4 and 8? Okay. So LCD, we would say, what can both 4 and 8 divide into evenly? They can both divide into 8. But I'm going to show you how to do it using factors. So 4 would be 2 and 2. 8 would be 2, 2, and 2, because it would be a 4 times a 2 and then a 2 times a 2. So when we're doing an LCD, we would pull out individual factors. So if I pull out a 2 from here, that also can account for a 2 over there. If I pull out a 2 here, that can account for a 2 over there. And then I still have another 2 remaining, which I must use. So the LCD would be 2 times 2 times 2, which is an 8. So the thing is that just like when we're doing simplifying, we can simplify fractions when we can look at them because we know our products and we know how to break them down. We know our factors. So like same thing with these two examples, we didn't have to use these factors because we just know that 6 is the number that 3 and 2 can divide into, the smallest number they can divide into evenly. And we know between 4 and 8, 8 is the smallest number that both of those can divide into evenly. However, we are not in a luxury of just having basic math problems. We are in algebra now. So what that means is we have to understand how to pull out factors of each denominator and use the factors to figure out what the LCD is, because we are going to have problems that contain variable components. So when we're looking at this, 1 over 3x and 1/2, the LCD would be 3 times 2 times an x, which is 6x. Okay, if we have 1 over 4x and 1 over 8x squared, so the LCD would be, we know it's 4 and 8, it's 8. What about for these x's? What do we use? Well, we would have an x, and then x squared would be what? An x and an x. So what are we going to use here? X and an x, right? Because 1x represents 1, and then we still have another one present. So the LCD would be 8x squared. All right, so when you have variable components, the LCD, you're going to take the variable that has the higher exponent in that pair. So when we're looking for the LCD, we have to keep in mind that we're going to have to use factors because everything is not just going to be simple numbers. And so we have to think in terms of factors not just our basic numbers. All right, so let's look at some more. Okay, let's look at these two. So we have 5 over 6x cubed, 11 over 8x to the fifth. So the LCD is what we're looking for. So 6 and 8. So we're going to use a 2, a 2, and a 2. And we have to use the 3. And then x3, x5. So what do you think we're going to use? We're going to have to use x5, right? Because x5 will contain x3. So when we multiply all those together, 24x to the fifth power will be the LCD. Okay, so when you look at it, 6 and 8, the smallest number 6 and 8 can both divide into is 24. And then x cubed and x to the fifth, the smallest one that they could both divide into would be x to the fifth. All right. Then we have here 4 over x squared plus 4x, and then 3 over x4. So we want to go back to our instructions that says find factors for each denominator. Finding the factors for each denominator basically means factor each denominator. And then you identify factors. So x squared plus 4x would factor into x times x plus 4. This x plus 4 is already factored. So when we look at to identify our factors, what are we going to use? I'm going to use an x, and then I'm going to use an x plus 4, and that accounts for both. So I'm done. So the LCD here would be x times x plus 4. Okay? All right, let's look at this one. All right, so we are looking for the LCD here. We're going to have to factor it first. So x squared minus 1. And then x squared minus 1 is the difference of two squares. So x plus 1 and x minus 1. Here, x squared minus 2x plus 1 would factor into x minus 1 times x minus 1. So when I'm looking for my LCD, we're going to pull out the common factors. What do we see? I see a 5. Check. I see a x plus 1. I see a x minus 1. And I see another x minus 1. Okay? So it would be 5 times x plus 1 times x minus 1 squared. All right? So each factor you pull out, if there's one in the other denominator, you can account for that one. Right? So that's how you're doing it. So that's finding the LCD. So you look at the denominator, you factor it, and you pull out the factors. Okay? All right, let's look at another one. Okay, so for this particular problem, we have these two fractions, and we're trying to identify the LCD. We can't do anything without factoring each denominator. So we factor the denominators. All right, so factors of 3, they give me 4, 3, and 1. Factors of 21, they give me 10, 7, and 3. Again, you got to know how to factor. So when I look for my LCD and I start pulling out my factors, all right, what do I see? I see an x plus 3. So that accounts for that one and that one. I see an x plus 1. And I see an x plus 7. So you just go through and you account for all your factors and you just check them off. And that's it. All right, so that's finding an LCD. All right, so we're moving straight into 7.4, which is adding and subtracting rational expressions with unlike denominators. So let's look at 1/2 plus 1/3. So we need to add these fractions. So we already know how to find LCD. So 2 and 3 have a least common denominator of a 6. Yes? Yes. So when you create a new denominator, you still have to create the new numerator. And so again, this is just adding and subtracting basic fractions. This is a basic math concept. So we're just starting at the bottom so we can evolve to the algebraic components. So 1/2 changes to a denominator of 6. So what do? We have to create the equivalent fraction. So once you find the LCD, then you have to create the equivalent fraction. So you found the new denominator, now you have to find the new numerator, essentially is what we do. So how do we go from a 2 to a 6? What did you multiply by 2 to get to a 6? So a 3, right? So whatever you do to the bottom, you do to the top. So that missing factor that created the 6 is the 3 that's missing. So it's 1 times 3, which is a 3. So how do we go from a 3 to a 6? So times a 2. Right? So you create the equivalent fraction. So you have to figure out what you multiply by 3 by to get to 6. And then you multiply that numerator by that same factor. So we multiply it by 2. So the numerator multiplies by 2. So we get a new numerator of 2. Then you're going to do it just like you did in the first part of 7.3, which is what? Combine them over, combine numerators over the LCD, and then you simplify. Okay, so we would do 3 plus 2 over 6, 5 over 6 is simplified as much as possible. And that's it. All right, so let's look at one. All right, so let's look at this. 3 over 4a plus 1 over 8a. So first we need the LCD. So the LCD here, for 4 and 8, the LCD is 8. For a and a, the LCD would be a. So we have an LCD of 8a. Okay, so now we have to create the new numerators. So what was missing? 4 to get to the 8 and missing the 2. So times 2. So my numerator is going to become 6 over 8a. The second fraction, 8a, stayed 8a. So nothing changes. So it's just a 1. So now we have the common denominator. So we combine them. 6 plus 1 is 7. So 7 over 8a. And of course you could do, what, 6 plus 1 and then 7 over 8a. Nothing can simplify. We're finished. All right, so let's look at this. 10x over x squared minus 9 minus 5 over x plus 3. So first we need to find the least common denominator. So again, that's the second part of 7.3, which was at the beginning of this video. So what do we have to do to find the LCD? Well, I got to break everything down into factors. So x plus 3 is factored already. I can't do anything with that. But x squared minus 9 can factor into x plus 3 and x minus 3. So we're going to identify our LCD. So our LCD here would be x plus 3, check, check, and then x minus 1, x minus 3, check. So I've accounted for all of my factors. So I'm going to create my new fractions now. So x plus 3 times x minus 3 minus x plus 3 times x minus 3. So now we have to figure out what's the new numerator. So from the first fraction, if this is my denominator here, because that's what x squared minus 9 factors into, nothing changed from the first fraction to the new fraction with the LCD. So therefore, my numerator won't change. So the 10x can just come down. In the second fraction, though, when I look at what I had an x plus 3, and that's all I had. So what factor is missing from x plus 3 down to the new LCD, which is x plus 3 and x minus 3? Well, the factor that's missing is x minus 3. So I have to multiply my numerator by x minus 3. So you can do it up there and distribute, or you can write it here and then distribute afterwards. So I'm going to write 10x, and this is here. Pay attention. I'm going to just write it as 1. I'm going to do every step for you so you can see it. So then when I try to simplify, because I'm combining my numerators over the LCD, I have to distribute to get rid of these parentheses. So negative 5x plus 15. So 5x plus 15. So I'm just combining like terms, right? So I distributed negative 5. I got negative 5x plus 15. Then I have like terms. 10x minus 5x is a 5x. Bring down my plus 15. So now I'm looking at my problem. I have a rational expression here that I need to see if it can simplify. So I can factor, my numerator can factor over. So then what can cancel? X plus 3, x plus 3. So my final answer is 5 over x minus 3. And you're finished. So you are literally using your stuff from 7.1 and from 7.3. Once you get that single rational expression, you factor where possible, cancel like factors. That's what we mean when we say simplify. All right, next. All right, so 5 over x minus 4 over x minus 3. So my denominators cannot factor anymore. So my LCD would just be x minus 4 and x minus 3. So I'm going to create my LCD. All right. So now I'm going to create my new equivalent fraction. So in the first fraction, x minus 4 is already there. So what's the missing factor? The x minus 3. So 5 times x minus 3. Remember, whatever's missing has to multiply to the numerator. So then in the second fraction, the x minus 3 is present. What's missing? The x minus 4. So 4 times x minus 4. So then we are just going to write everything over the same common denominator and combine. So I'm going to go ahead and distribute before I actually write it. So 5x minus 15 minus 4x plus 16, right? So I distributed already. So I can put a line in here for you though. So I wrote that line in there so you can just see. All right, so then we're combining like terms. So 5x minus 4x is x. Negative 15 plus 16 is a plus 1 over x minus 4 times x minus 3. So everybody's factored and nobody can cancel. So I'm done. And that's it. All right, let's look at this one. Five over 2x plus 10 plus 3 over x squared minus 25. So I have to factor so that I can figure out what the LCD is. So the first denominator would factor into 2 times x plus 5. The second one is the difference of two squares. So now I can figure out my LCD. So I know I'm going to use a 2. Check. I have an x plus 5, so that'll account for that one and that one. And then I have an x minus 5. So that's my LCD. So now I'm going to create my denominator. So what was missing from the first fraction to this new fraction? So my denominator is the 2x. 2 times x plus 5. Look at the factored one, not the multiplied one. So the only factor that's missing is the x minus 5 factor. In the second fraction, the only factor that's missing is the what? The 2. So we account for the missing factors in the numerators, and now I'm going to combine. So 5x minus 25 plus 6. So I combine like terms. 5x minus 19 over 2 times x plus 5 times x minus 5. And that's it. So 5x minus 19 can't factor. The denominator is already factored. Nothing cancels. The problem is over. So you find your LCD. You have to create the equivalent fraction by figuring out what's the missing factor. You combine your numerators over the LCD and you simplify. So you combine like terms in the numerator, then you see if you can simplify your fraction further. Okay? And that's how you add and subtract rational expressions with unlike denominators. All right, so I'll put this problem here. 4 over x squared plus 2x minus 15 minus 7 over x squared minus 2x minus 3. I want you to figure out this problem. So you should pause the video and work this out. And I'm going to work it out too. Okay. So the LCD should have been x plus 5, x minus 3, and x plus 1. So when we factor our denominators, the first one would have been x plus 5, x minus 3. The second denominator factors into x minus 3 and x plus 1. So if you didn't get it, just pay attention, see if you factored incorrectly, because then you just would have pulled out each factor to be your LCD. All right, so then here, all I did was I just rewrote this new factor denominator. So I just wrote new fractions. That's all I did. So then I created my equivalent fraction. So I have the LCD, and then what factor is missing from the first fraction to the new fraction. So I have the x plus 5 and x minus 3. I'm missing the x plus 1. So when I put that there, it must also multiply to the numerator. In the second fraction, I have the x minus 3 and the x plus 1. It's missing the x plus 5 factor from the LCD, so that multiplies to the 7. And then I distribute it. Remember, it's a negative 7. And then I just combine like terms. And when I combine like terms, the numerator doesn't factor, so nothing cancels. And that's adding and subtracting. Okay? And that's it.